Hello, yeah. In this video, I want to talk about how to compute the whole moving average of a time series using R. So the whole moving average is a technical tool used in trading to identify trends more clearly and faster than traditional moving averages. Okay. So it was developed to reduce the delay often seen with older moving average methods, making it respond quicker to recent price changes. Okay. The HMA uses the specific weighted calculation that focuses more on the latest prices while still smoothing out fluctuations, helping traders spot market direction with less noise. And this method aims to combine the benefits of being both smooth and responsive, so traders get timely signals without confusing jittery moments. Okay. So it is widely used to find trends, determine entry and exit points, and can be combined with other indicators to make better trading decisions. Okay. So basically, HMA is a filter. I think it's a low-pass filter to smooth out certain noises. It's still showing general trend, but it's gonna focus on more recent data, so it will capture the new data trends more quickly. Okay, so it's a very useful tool. I want to show you how we can calculate using R. Okay, so first you need the package TTR, which we need that function for calculating moving averages. And I want to generate a Trellis graph, so I load the library lattice, set random seed, sample size 100, generate a time series using the cum sum function, and just adding up a bunch of standard normal random variates. And now here is the command we're generating different moving averages. It's called the SMA function, and EMA function, WMA function, HMA function. And syntax was very similar for these functions, just data, TS underscore data. Then we need a window, so n equal to 10. So that's the sliding window we're using to calculate the averages. Okay, so, and the calculation is very fast using R. And then we prepare the data for Trellis plots. So we just combine this variable time is 1 to n, original data, the TS and score data, and then these moving averages. Okay. And we do some data manipulation here. So reshape the data to long format for lattice. So we can create a series list. Just put all those computed moving averages into this list. And then get all the names. Now we use the do.call function. Use the rbind, L apply, seg underscore long series list and the function of I, and then just do data frame, a time equal all these, and then the MA equal to series underscore list of I, and the type equal to all MA names of the I's, component of that list. Okay, so, and then we make it the factor, the type is factor. And then now we can use the XY plot, the original versus each MA in a 2x2 grid. Okay, so XY plot, original plus MA tiered time conditional type using this df underscore long data set, and type equal to line, and line width is 1 and 2, color black and red, and layout 2x2. Auto key and okay. So on the right hand side, you can see it generated WMA, HMA, SMA, and an EMA. Okay. So if you look closely for the HMA, it's actually, you can see here, it captures the movement of the original data much faster. So there's almost no delay. But for the other, the WMA, the SMA, and the EMA, they all show noticeable delays. Okay, they're not catching up with the new trend, new data quickly enough. Okay. All right. So this is just showing a way to calculate HMA of a time series in case you need it. Okay. If you like this video, please subscribe to our learning channel and click on the notification bell. And feel free to share this video with other learners. And also, you're welcome to ask any questions in the comments area. And I will respond to that. Thank you much.